All right, IBAISL2. Today we're going to talk about the area between two curves, and we're going to really embrace the graphing calculator for this. So before we get to any calculator steps, let's just talk about the concept. If you have two functions, like an f of x and a g of x, or like a y1 and a y2, usually or sometimes these two functions will cross each other. Today we're going to talk about the area that's in between the two curves using integration. So, you guys, if these cross at a something and b something, you don't really need to know the y values. The y values don't matter. It's just the x values. You can find the area between these two curves by integrating from a to b and then subtracting the top function minus the bottom function with respect to x. So notice that this top function here is y1. So that part has to go first. So you're doing top minus bottom. So the bottom function is y2. So it's y1 minus y2. So it can kind of, change and depend on what the graphs look like, depending on, if you want to do y2 minus y1 or y1 minus y2. One function subtracted by the other. Now, we're going to do a bunch of examples today. And the first one you can kind of do by hand. So I'm going to show you how you can use algebra to do these things, but then very quickly how there's certain things you can't do with algebra and you need to embrace the graphic calculator. This one we are going to use algebra on. Find the area of the region bounded by the curves y equals 4 minus x squared and y equals x plus 2. So first things first, if I graph this on a calculator, the y equals 4 minus x squared is an upside down parabola, and then the y equals x plus 2 is this line. We need to figure out what these intersection points are to figure out what x values those are, because that's what we're going to integrate from. To be able to figure out where two things cross each other, you can set them equal to each other. Now this is a quadratic, so I'm going to move everything to one side. Subtract 4 and you get negative 2. Now, does this factor? Yeah, it does. So it's going to be plus 2 minus 1. So set those equal to 0 and you get, I'll put them in the other order, negative 2, positive 1. So that means this is the point negative 2, 0. You can get the 0 by plugging it back into the functions if you want. And this is the point 1, 3. When we integrate this to find this area, we are just going to go from this x value to this x value. So this will be, do a little line of separation here. The area is negative 2 to positive 1. And then the above function is 4 minus x squared. So it'll be 4 minus x squared minus x plus 2 dx. So now we need to integrate this. Before we integrate it, let's just let the integration symbol hang out. We can clean up the inside. So if you subtract, if you distribute this negative and then add like terms, I believe we get 2 minus x squared dx. Then integrate that and you get 2x minus 1/2 x squared minus 1/3 x cubed. And it goes from negative 2 to positive 1. Then if we plug those things in, we get 2 times 1 minus 1/2 times 1 squared minus 1/3 times 1 cubed, and then subtracted by 2 times -2 minus 1/2 -2 squared minus 1/3 -2 cubed. And then this, if you simplify it, is 2 take away 1/2 take away 1/3 minus -4 minus 2 plus 8/3. And then if you do some common denominator work, I think the whole area turns out to be 9/2. So that is the area between those two curves. Now, if we try to find the area bounded by these two curves, first of all, if you put this into y1 in your graphing calculator and then put this into y2, you get a picture that looks like this. There's a linear, there's an exponential, and then there's an area between them right here. Now, if I set those two things equal to each other, yes, it can be solved with a lot of logarithms and things, but like I said, we're kind of embracing the calculator. So what you guys need to do is graph both these things and then use the intersect function, which I'll try to find a pre-made YouTube video about finding intersect, but it's like in the calc function right above trace. So we're going to say use intersect function to solve this. So instead of using a bunch of algebra and logarithms, we're going to use the calculator. Those two spots in terms of x's, when you solve them, are negative 2.998 and positive 0.6469. That means that we are going to integrate from negative 2.998 all the way up to 0.6469. And then what we are integrating is going to be the top minus the bottom. Now the top is the line and the bottom is the curve. So we'll do x plus 4 minus e to the 2x plus 1 with respect to dx. Now, you guys, since we're going full-blown calculator, you don't have to integrate this by hand. You could do this one by hand with like a little baby u substitution and stuff. But since we're going full calc, you can use that function that we showed you guys about how to find the integration, the fn int. And when you do that, this is 4.83. Whoa. So, embrace the calculator. Sorry, here's the whole problem. This one is interesting because we're going to embrace the calculator once again. If you graph this cubic and this square and adjust your window, you get a picture like this. Now, this is interesting because we need to find this area plus this area. The thing that's curious about this is that which function is on top switches. So like f of x in this section is on top, and then g of x is on the bottom. But then in the next section, g of x is on top, and f of x is on the bottom. First thing you want to do is use that intersect function to figure out these values, 1, 1, and 3, 9. Once you have those values, that means we're going to integrate well, this is also 0, 0 that they cross at. So they cross in 3 places. First, we need to integrate from 0 to 1, where f of x is on top. So this will be f of x minus g of x dx. But then we're going to have to add from 1 to 3, where g of x is on top and f of x is on the bottom. So this will be so it kind of switches which one you're subtracting, and that means you got to break it up into 2 separate intervals. So this whole thing will be equal to plugging in the f of x and g of x. Oh, I'm going to run out of room. Okay, we got to shift it down a little bit, you guys. So this whole thing is going to be 0 to 1, x cubed minus 3x squared plus 3x, and then take away x squared dx, and then we're going to have to add 1 to 3, where it's the opposite, that they switch places. X squared minus x cubed minus 3x squared plus 3x dx. Now, you guys, both of these are calculator crunchers. Yes, you could do them by hand, but we're embracing the calculator. So put these both into your calculator, and you should get 37/12, which is about 3.083. There's the whole problem. The last one is from chapter 13, because a lot of the trig they save for chapter 13. We're going to find the area of the region bounded by the sine of x and 0.5x. If you graph both of these, you'll see that they cross in 3 places. Using the intersect function, you're going to get some numbers that aren't super nice. So I think, yeah, if you use the intersect function to figure out where these are, this is an x value of negative 1.9, about. This is 0, and this is positive 1.9. Now, those are approximations, the 1.9 and negative 1.9. It's rounding to 2 decimal places. This is similar to the last problem, where this curve is underneath in this section, but then it's on top in the second section. So we actually have to break this up into 2 different integrals. The first one would be negative 1.9 to 0 of line minus sinusoid. So that'll be 0.5x minus sine of x dx. But then the next section is from 0 to 1.9, where it's switched, where the sinusoid's on top and the line is on bottom. So we get sine of x minus 0.5x dx. Now, both of these areas are going to be the same because they're symmetrical. So the book wants you to know that you could just take one of these and double it, that this would be the same as just doing like the first one and putting a 2 on the outside. But no matter what, it's going to be a straight calculator cruncher using that FN int button. So the area, when you plug it all into your calc, is 0.842. All right, you guys, ask me questions in class if you're having calculator trouble. I'll try to post some other videos on how to use intersect FN int.